All right, Longhorns, this is the review for the test 3.2 and for Algebra 2 Pre-AP. So we're going to begin with the first example. It says find solutions by graphing. On this one, I would simply take my graphing calculator. I would graph this on the graphing calculator, get some critical points, and then sketch a picture of the graph. All right, for this graph, I noticed that on my graphing calculator that I have two places where the parabola crosses the x-axis at 1, 0 and at 4, 0. So those would be the two solutions for this parabola. You can also get these solutions from the table if you do Control-T on your TI Inspire. You can find the solutions in the table wherever y is 0. So you look for at the table where y is 0, and the value for x is going to be your solution. Okay, on number 2, I find the solutions to be at -3, 0 and -5, 0. All right, in the next problem, we're solving the system algebraically. What we want to do is isolate one of the variables, and then we're going to set those equations equal to each other and solve for the other variable. So in this case, I have x equals y minus 5, and I also have another equation, x plus 2y equals y squared minus 3. So what I'm going to do is I'm going to isolate x, and then I'm going to set these equations equal to each other. So in this first step, I have simply moved this plus 2y to the other side of the equation. So I have x equals y squared minus 2y minus 3. Now I'm going to set this equation equal to this equation, and I'm going to continue solving for y. All right, so here you can see I have set these two equations equal to each other, and that eliminates x, and then I can go ahead and solve for y. I need to set this equation equal to 0, so I'm going to be moving the y that's on this side of my equation here, and I'm going to be moving this 5 as well over here, and then I'm going to factor this. All right, so what I end up with is, once I move this y value here, I subtract it from both sides, and I get -3y, and then I add 5 to -3, and I get +2. Now I'm going to factor this and find my two solutions for y. All right, so I know that a -1 times a -2 is a +2. So the two numbers that multiply together, or the product of that gives me 2, is 1 and 2, and -1 plus -2 equals 3. So this is how this will factor: y minus 1, y minus 2. Now I solve for y by setting that equal to 0, and I get y equals 1 or y equals 2. So I have my y value. Now I need to get my x value, and I'm going to do that by plugging it back in to one of the equations from my original problem. And I'm going to use the linear one because it's a little bit easier to do. But you can use either one, it doesn't matter. All right, so once I finished solving for y and I plug that back in to one of my equations, I'm using the linear one, I get that x equals -4 or x equals -3. So my two solutions are, when y is 1, x is -4. So when y is 1, I get x is -4. When y is 2, I get x is -3. So when you're solving for these, don't let that x and y variable confuse you. Just go ahead and solve it like you normally would. Make sure, though, when you write your solutions that you're writing these values in the right place, because this is still an ordered pair, x, y. So just make sure if you're solving for y first and you're plugging it in to solve for x, that when you write your final solution, you're still writing it as x, y. Don't flip-flop these or you're going to get the answer wrong. Also, once you get your solution, I would like for you to check your work by graphing both of the equations on your graphing calculator and check to make sure that your intersections are actually these points. If they're not, then you've probably made a mistake. So you can do that quick check just to make sure that you've done the algebraic work correctly. All right, with problem number 4, we're doing the same thing. I'm going to set this equation equal to y, and then I'm going to set the two equations equal to each other, and then we're going to solve for x this time. All right, so let's go ahead and add 2x to both sides. To this equation, we have y equals 2x plus 21. And now I'm going to set this equation equal to the quadratic equation and solve for x. All right, so I have set these equal to each other, and I set this equation now equal to 0 by subtracting 21 from 3, that gives me negative 18, and subtracting 2x from 5x, that gives me 3x. So now that I have my equation set equal to 0, I can factor it. So this equation factors out to x plus 6, x minus 3, because these two numbers multiplied together give me 18, and they add together to give me 3. When I solve for x, by setting this equal to 0 and solve for x, I get x equals negative 6 and x equals 3. Those are my x values. Now I need to find my y values by plugging these values for x back into one of my equations, and I'm going to use this one. All right, so when I plug these values back into my linear equation, I get y equals 2 times 3 plus 21, which is 27, and I get y equals 2 times a negative 6 plus 21, which gives me 9. So my two solutions are 3, 27 and negative 6, 9. And those are my two solutions. Please check it using your graphing calculator. Make sure that you didn't make any sign errors as you were doing your algebra or subtracting or adding incorrectly. Make sure that you check your work, use your graphing calculator, graph it, double check your intersections. You can also check your work by plugging these values back into the original equations and making sure that those statements are true. So either way, you need to check your work. Please check your work when you're done. Okay, for problem number 5, we're going to determine the vertex, axis of symmetry, and y-intercept of this equation. But the first thing I want to do is set this equation with a y equals, and then set that equal to 0. So we need to get this into the correct format. Okay, so I've moved some things around. I moved this negative x squared to the other side of the equal sign. I also subtracted this 12x, and I added 36. So I ended up with y equals x squared minus 12x plus 36. Now I'm going to set this quadratic equal to 0. That means I'm going to make y equal 0 in order to find the other information I need. Also, from this form right here, this is the standard form of this quadratic, I can get the y-intercept by making x 0. So if I make x equals 0 here and here, I get the y-intercept of 36. So right away I've gotten my y-intercept just from doing this piece. All right, the next thing I'm going to do is put this equation into vertex form. So to put this in vertex form, I need to create a perfect square. Well, if I look at my equation the way it is right now, if I take half of negative 12, which is negative 6, and I square that, I get 36. So this is already, it's already a perfect square. So I'm just going to rewrite it as a perfect square. All right, so that's x minus 6, the quantity squared. You can also do that if you wanted to factor that using a box to just check your work to make sure that's correct, you can. Or if you wanted to FOIL back together the x minus 6 times x minus 6, you could do that. But what you need to make sure that you know how to do is check this middle term. If you get the last term, check this middle term. If you cut it in half and square it and you get the last term, then this is already a perfect square. So you need to be able to recognize these things when they happen. All right, so this is a perfect square. This is my vertex form. My k is going to be 0. So my vertex is going to be 6, 0. All right, so the axis of symmetry is always the same value as the x value of your vertex. So the axis of symmetry is a line, so we need to write it as a line, x equals 6. So this value for 6 and the value for the x in the vertex should be the same number because the axis of symmetry goes through your vertex. Just make sure that you write the axis of symmetry as the equation of a line, x equals 6. All right, with number 6, we're going to do the same thing, except we may have a couple of extra steps. So I'm going to go ahead and solve this for y and make it y equals and then some equation. All right, so for my first step, I've moved the x term to this side. I've also moved the 6, subtracted that, the 6x, subtracted that, and subtracted the 18. So I ended up with 3y equals negative x squared minus 6x minus 18. Now the next step I need to do, I still need to isolate y. Y needs to be by itself. So I'm going to have to divide everything by 3. All right, so after dividing by 3, I end up with negative 1/3, because when I divide x by 3, I get negative 1 over 3. So negative 1/3 x squared minus 2x minus 6. Now I can find the y-intercept from here, from the standard form, just by setting x equal to 0. So when I set x equal to 0, this becomes 0, and this becomes 0. So my y-intercept is negative 6. Okay, here I've written the y-intercept is 0, x is 0, y is negative 6. All right, next we need to find the vertex and the axis of symmetry. So I'm going to use completing the square to help me find the vertex. There's also another little formula we can use to find the vertex and the axis of symmetry. But I want you to practice completing the square, so we're going to do that instead. All right, so what I need to do is I need to set this equation equal to 0, and then we're going to do all the steps we need to do to complete the square. I'm going to go ahead and do all of those steps, and then I'll explain what I did. All right, so far what we've done is rewrite our equation again. I rewrote it so that I could see this negative 1/3 x squared minus 2x equals 6. So all I did was take this negative 6 and I moved it to the other side of the equal sign, but I rearranged the equation so I could get it in the right order. And then I factored out the negative 1/3. So when I factor out a negative 1/3 from this equation, I get negative 1/3, the quantity x squared plus 6x. So remember, I'm dividing negative 2 by a negative 1/3. So that's going to change this sign to positive. And then this number becomes 6. So 2 divided by 1/3 is 6. x, the quantity, and then we have equals 6. So now what we're going to do is we're going to take this amount right here, and we're going to finish completing the square, and then get the vertex form. That's going to give us our vertex and our axis of symmetry. Alright, so before I complete the square, I wanted to show you how I set this up. Alright, so I have a negative 1/3 is my coefficient out here on the outside this is the negative 1/3 I factored out. And then I have an x squared plus 6x plus, now I need to complete the square right here, so I'm going to have to put a number here that completes this square. And I'm also going to add that same number here. But remember, we factored out a negative 1/3. So that means I still need to multiply this number over here also by a negative 1/3. So what number do we need to fill in here? Well, half of 6 is 3, and 3 squared is 9. So we're going to put a 9 in here. And we also need to put it in here. So don't forget that we're multiplying these together. Now I'm going to rewrite my equation as a vertex form, and then we're going to find the vertex and the axis of symmetry. Alright, so after finishing up completing the square, we get that we have a negative 1/3, x plus 3, the quantity squared, equals 3. Move the 3 over here, make it negative, and we have the vertex is negative 3, negative 3, negative 3, negative 3. And the axis of symmetry is x equals negative 3. Please, please, please make sure you check your work by graphing both of the parabolas. They should make the same graph. It's just a quick way to check to make sure you haven't made any mistakes with any negative signs or any adding or subtracting mistakes or multiplying mistakes. All those little kinds of mistakes can throw your whole problem off. If you graph this parabola with your original parabola, they should make the exact same graph. Okay, so for problems 7 and 8, we're writing each equation in standard form. So we're writing this equation from the graph. If you remember from the homework assignments, we actually wrote the vertex form, but then we can convert the vertex form to the standard form. So what I'm going to do first is I'm going to write this equation in vertex form, and then we're going to convert the vertex form to standard form. Okay, so the vertex form was fairly easy to find on this graph. I found my vertex point, which is right here, and this is point 3, negative 4. So that was easy to just plug into my vertex form of the equation. And then I found my value for A simply by going up 1 and over 2 units to find that I have a value of 1/2. The next thing I'm going to do is break this binomial apart, this x minus 3 squared, and I'm going to break it apart into its two parts. I'm going to FOIL it, and then I'm going to simplify. And what I get in the end is my standard form. Alright, so I FOILed that back together, and I got x squared minus 6x plus 9. And then I had to distribute this 1/2 through this trinomial right here, and I got 1/2 x squared minus 3x plus 4.5, and then I subtracted the 4, so I got 1/2 x squared minus 3x plus 1/2, and that's my final standard form for this graph right here. Alright, so I got the vertex form and I got the standard form, and you can graph both of these and make sure that these match this graph and that they match each other. As long as that happens, then you're good. Okay, so for question 8, we're doing the exact same thing. Alright, so we have our vertex form right here, negative 1/2 times the quantity x minus 6 squared plus 5. We get that from our vertex, which is 6, 5, and our a value, which is, if we go down 1 and over 2, that gives us our A value. That's where we have our next point on our parabola. So down 1 over 2, down 1 over 2. And it's negative because the parabola is opening down. So negative 1/2 is going to be our value for A. You can also substitute in like we did on the homework, where you take one of these points and you substitute it in to the equation and solve for A. You're still going to find that you get a negative 1/2. Okay, so then we go ahead and we break this apart into its two binomials, FOIL it, we get x squared minus 12x plus 36. Distribute the 1/2, and we get negative 1/2 x squared plus 6x minus 18 plus 5. And then the last thing we do is combine these two numbers, and then we get negative 1/2 x squared plus 6x minus 13. Make sure that you graph this and graph this, and make sure they all match and that they match the graph here. And as long as all of those three things happen, then you're correct. Okay, so for numbers 9 and 10, we're converting to vertex form from standard form by completing the square. Okay, so here you can see I have worked out this whole problem. We have negative 3x squared minus 12x minus 16 equals 0. I set it equal to 0 first. I move the 16 over to the other side of the equal sign. I get negative 3x squared minus 12x. I then factor out the negative 3, and I get negative 3 quantity x squared plus 4x. Now the sign changes to a positive, so be careful about that. When you factor out a negative, this sign changes. Then I'm going to complete the square. So whatever I add here, I also need to add here. And I need to multiply it times a negative 3 because I factored out a negative 3. So both of these ends need to be multiplied by negative 3 for this to be correct and to be balanced. The next line, I am completing my square. I add 4. So half of 4 squared is 4. I'm going to add a 4 to both sides. Here's my 4 here and here's my 4 here. I then rewrite this as a perfect square. That's x plus 2 squared. Of course, I have my factored negative 3 over here. And then this equals 4 when I get done simplifying that. So that's 4. So I have a negative 3 quantity x plus 2 squared minus 4 equals 0. This is my vertex form. Then I go to my graphing calculator, I graph this one, and I graph this one, and I make sure that they make the same graph to check my work. Now we're going to do the same thing with number 10. All right, so here's number 10, and I did it exactly like the other one. We have 20x squared plus 160x plus 325 equals 0. So I set my equation equal to 0. I then moved my 325 over, so now I have it equals to negative 325. Then I factored out my 20, and I have a space left here to complete my square. But remember, when we add this number over here, we also have to multiply it by 20. Then we have our perfect square, which is x squared plus 8x plus 16. So we added 16 here. Don't forget to multiply times 20. Then we rewrite this as a perfect square, x plus 4 squared. So 20 times x plus 4, the quantity squared, equals negative 5. Then move the negative 5 over to the other side, and voila, you have your vertex form. Don't forget to graph. Graph this one, and make sure that they match. For problems 11 through 16, we're going to write each equation in standard form. I'm going to quickly work these and stop to explain when necessary. All right, so I worked out this problem number 11, and I found that the equation for vertex form is y equals a times x minus 6, because the vertex is 6, 7, minus 6 squared plus 7. So I put it in vertex form first. And then I find the value for a by plugging the other point in. The other point was 419. So I put 19 in for y, I put 4 in for x. I simplify this and I find that A equals 3. Then I use that information to rewrite this in standard form. So I break this apart into its two binomials, FOIL it together, distribute the 3, simplify, and I get 3x squared minus 36x plus 115. Now, what you need to do to check this is, first of all, check to make sure that this equation is correct by graphing it, and make sure that these points 6, 7, and 419 are on the table, and that 6, 7 is indeed the vertex. So the points before and after this point right here should be the same. Then graph this one after you get it against this one to make sure that that's the same parabola. As long as those are the same and as long as these points are on your graph, then you have done this correctly. Now I'm going to do the others real quick just to give you some check figures. I'm not going to walk you through each one of these, but if you have any questions on these, that's what you need to bring to class. All right, for number 12, we have a parabola with a vertex of 10, 7, and it passes through the point 11, 5. And this is how I worked this one. Again, I used the vertex form first. Went ahead and found the value for A, plugged this back in, converted that to standard form. I checked here, I checked the parabola for these points to make sure that they're on this parabola. I also graphed this one to make sure that this graph matches this graph. So that's all you have to do. And then we're going to go on to number 13. All right, for problem number 13, we are creating a standard form quadratic equation from 3 points. And for this one, we use the standard form of the quadratic. We plug the values in for x and y into the quadratic form equation. And the first solution we get for the first point is we get this equation 20 equals a times 4 squared, because x is 4, plus b times 4, x is 4, plus c. So our first equation is this, 20 equals 16a plus 4b plus c. So if you notice, at the first one we square x and the second one we don't. So whatever x value is, this number here is always going to be that number squared. Okay, so 20 equals 16a plus 4b plus c. And the next one, my x value is 0. So that means that these values are all 0, so I just have 20 equals c. And in my last point, I have x equals negative 1 and y equals 11. So I put 11 in for y, and negative 1 squared is 1, so that's going to be a positive a. And the negative 1 times b is negative b plus c. Now I have these three equations that form a system, and now what I can do is use my graphing calculator to type these equations into the solving systems of equations function in my calculator, and I can find the values for A, B, and C, and that's what I'm going to do next. So when you enter this into the calculator and you're solving the system, you need to make sure that for A, B, and C, you're actually using X, Y, and Z in your graphing calculator, because it's set to read X, Y, Z, not A, B, C. So just change A, B, and C to X, Y, and Z when you enter it into the calculator. And when you solve the system, you get x is negative 9/5, y is 36 over 5, and c is 20. Or a is negative 9/5, b is 36 over 5, and c is 20. So when we put it into our quadratic equation, this is going to be our a, b, and c. So a ends up being negative 9/5, b is 36 over 5, and c is 20. And that's it. Oh, the other thing I want to mention as well, make sure that you graph whatever equation it was that you got when you did this, and make sure that these 3 points that are in the problem that you used to set up your systems, make sure that those 3 points are actually on your graph. So you want to check your table and make sure those points are there. Okay, so this is what the entire problem looks like completed for number 13. Let's go on to number 14. All right, so here's number 14 worked out. I created my 3 equations, and so here are the 3 equations from these 3 points. I create these 3 equations, solve this system. I get 1/2, 8, and 27. I write my equation, 1/2 x squared plus 8x plus 27. I graph it to make sure that these points are on the table. Everything checks out, so I'm done. Okay, in problem 15, we're given solutions. So there are 4 different ways to express solutions, and we can call them solutions, or we can call them zeros, or we can call them x-intercepts, or we can call them roots. So any one of those words are synonymous. So just make sure that you understand that. So if you see a question like this, if it says something besides solutions, so if it says roots, or if it says zeros, or if it says x-intercepts, you'll know what that means. Now what we're going to do first is we're going to write these as factors, and then we're going to multiply the factors together to get our standard form equation. All right, so what I've done is I've taken both of the solutions and I've set them equal to x. So x equals 3/4 and x equals -6. And then I'm going to set that equal to 0 by undoing these operations I have here. Right here I have a -3/4. So to undo this and put it back the way it was before it became -3/4, I'm going to multiply both sides by 4, and I get 4x minus 3. And then I'm going to add the 3, so I get 4x plus 3. So this is the factor that gave me the solution of -3/4. Then I'm going to do the x. Well, this one's easy because all I have to do is add 6. So x plus 6 equals 0. So now I have my 2 factors, and I take my 2 factors and I multiply them together. I can FOIL or use the box method, whichever one that you prefer, doesn't matter. And when I multiply those together, I get 4x squared plus 27x plus 18. And I go ahead and graph that and make sure that these actually cross the x-axis at these points at -3/4 and -6. And as long as that's good, then my equation is correct. If not, then I need to go back to see if I made a mistake somewhere and fix it. So for number 16, I do the same thing. I'm going to rewrite those solutions as factors and multiply them together. All right, so for number 16, I set this equal to x equal to -8 and x equals 5/2. I get x plus 8 for one of the factors. For the other factor, multiply by 2, subtract 5. 2x minus 5 equals 0, that's my other factor. I multiply my 2 factors together, and I get 2x squared plus 11x minus 40. Then I graph it to check to make sure that this graph actually crosses the x-axis at -8 and 5/2. And as long as it does, then it's good to go. All right, for number 17, we're going to factor to find the 2 critical points, and then we're going to shade the number line based on what we find for our critical points. We know that this parabola, the factors need, when you multiply them together, need to be less than or equal to 0. So we are going to see how that works when we factor this out. All right, so I used the box method to factor this quadratic equation. Since my a is greater than 1, it's a 2, I went ahead and used this box method to factor this. And I got the factors x minus 5, 2x plus 1. Then I solved both of those for 0, so I could find out what my critical points are. And I got one of my solutions is 5. The other solution was negative 1/2. So I plotted those on my number line, and I colored them in dark because this is less than or equal to. So since it's equal to, I went ahead and colored those in. And then I used 0, the number 0, which is right here. I used the number 0 to check to see if I should shade inside or outside the points. And so since I plugged 0 in, this is 0, this is 0, and since negative 5 is less than or equal to 0, that makes this statement true. I shade inside. So this is why it's shaded in between the points. And that's all there is. So for number 18, we need to set this equation, or actually it's an inequality. We need to set this inequality to 0. So we need to move some terms around and get this in the right form, because right now we have two expressions on each side of this inequality, which makes it very difficult for us to see what we have. So let's go ahead and rearrange it, and then we'll see what we need to do to factor. Okay, so the first thing I did was rearrange this by moving all of the terms on the right side of my inequality over to the left side. So I first added a y squared to my negative 2y squared. I added 1. That gave me a negative y squared. I then subtracted 4y from 13y. That gave me 9y. And then I subtracted this 6 from this 6 and got 0. So what I ended up with was this negative y squared plus 9y. Now to factor this, all I'm going to do is factor out the negative sign and a y, because these both have a y in common, and they both have a negative sign in common. So I factored out the negative y, and I got negative y, and then my other factor is y minus 9. So when we factor out that negative sign, our sign changes inside here to a negative. So my two solutions are negative y equals 0, so y equals 0, that's one of them. And then the other one was y equals 9. So my critical points are 9 and 0. But since this is a greater than symbol, I'm going to use an open circle. So right here at 0, I have an open circle. And right here at 9, put a 9 in there. Right there at 9, I have an open circle. And then what I'm going to do, instead of using, I'm not going to use 0 to check, because that's my critical point. So I'm going to use something other than 0. Well, the other number that's really easy to use besides 0 is the number 1. So I'm going to check this point right here. So I plug 1 in to check. So when I plug 1 into my equation right here, my inequality, I'm sorry, when I plug 1 into my inequality, I get negative 1 squared plus 9, and is that greater than 0? Yes, it is, because negative 1 plus 9 is 8, and 8 is greater than 0. So we're going to shade inside. So we shaded inside between the critical points. So don't forget to check using one of the numbers on your number line to make sure that you're shading it in the correct place, because sometimes these negative signs will throw us off and you'll end up shading in the wrong place. So just make sure that you check where you're shading by using one of your points that's inside the region that you're trying to check. Okay, there's not a lot I can do about the next several problems to show you on this video, since I can't really show you what the graph looks like, but we can do these in class. I can, however, give you the solutions so that you can check your own work, and that's what I'll do. And so you really need a graphing calculator to do problems 19 through 22, because that's how we did it in class. You can do them by hand, it's just a lot more work to do them by hand, and since we have the graphing calculators and very little time, we're going to use the technology to help us through it. So let's go ahead and I'll go ahead and solve these, and then I'll give you some check figures, and then you can try it on your own. All right, in problem 19, the equation is going to be negative 16x squared plus 45x minus 6. And when I graphed that, I found that the maximum point, the height, the value for y, was 25.6 feet. All right, for problem number 20, the equation is going to be negative 16x squared plus 12x plus 136. And I graphed that, but I also graphed the line y equals 40 so that I could have an intersection that I could get from my graph that would give me the exact point where the object would be 40 feet above the ground. So I went ahead and graphed a y equals 40 line as well. And the intersection where those two graphs cross, the x value was 2.85 seconds and the y value was 40. All right, in this problem number 21, the equation I used was negative 4.9x squared. Since this one's in meters, I'm using the negative 4.9. And the velocity was 6.5, so it's negative 4.9x squared plus 6.5x plus 3. I graphed that, and I found where the graph crosses the x-axis, because that would be at the point where she hits the water, would be at 0. So I'm looking for the 0, and I find that at 1.69 seconds, the graph crosses the x-axis. So 1.69 seconds is how long it takes for her dive before she hits the water. Okay, so for number 22, the coordinates for the intersecting point were 4, 7. Okay, for number 23, we're just looking for the value for x when the arrow hits the ground, and that value was 2.6 seconds. All right, the next problem is an area problem, and I'm going to go ahead and explain that one down here at the bottom of the page. So Mrs. Vaca wants to frame her oil painting that she crafted. If the dimensions of the picture are 40 inches by 24 inches, and she adds a frame of uniform width on each side, creating a total area of 1,350 inches squared, find the dimensions of the frame. Okay, so first of all, we're going to draw a picture, and then we're going to write an equation that represents our picture, and we're going to solve. All right, so for this problem, we have a picture that is 24 by 40, and we have a frame of uniform width on each side, creating a total area of 1,350. So what we have to do is we have to take the side dimensions of the picture and add 2x for the frame, for each side of the frame. So we end up with 40 plus 2x times 24 plus 2x. That gives us this length right here and this length. And we multiply those lengths together, we get 1350. So if I set that equation equal to 0, I have 40 plus 2x times 24 plus 2x minus 1350 equals 0. And I can graph that, and then I'm going to check the parabola to see where it crosses the x-axis. Well, it crosses the x-axis at 2.8. So my width of my frame is 2.8. So if I plug 2.8 in for x, that will give me the length of the long side, which is 40 plus 2 times 2.8, which is 45.6, and then the length of the shorter side, which is 24 plus 2.8, or 2 times 2.8, which gives me 29.6. So the dimensions of the entire frame are 45.6 by 29.6. Now in the next problem we have Coach Pierce was tired of Shelby missing shots. She explained to her that the dimensions of the inside of the white rectangle on the backboard were were 20 inches by 14 inches, with the white rectangle having a uniform width. If the total area of the rectangle on the backboard is 432 inches squared, how wide is the white stripe and why can't Shelby aim for it? All right, so I'm not sure I understand what they're trying to say in question 25. So I am going to check with Coach Reeves and Miss Vaca on this one, and I will have to get back with you guys in class on question 25. If I get an answer that I can explain to you, I will certainly do that at the end of this video or in class on Monday. Make sure you bring any questions you have about the review to class on Monday so that we can make sure that we're covering those areas that you're not understanding. So be sure to go through the review, make sure you understand all the problems, and if there's any place that you're having difficulty or you need further explanation, please bring those questions to class prepared to ask, and I will answer them the best I can. Good luck on your test on Tuesday.